It looks like quite a bit of variety from here.
The lunar landings of Apollo showed what the moon is made of. About 30% metals like aluminum and iron, 20% silicon, 40% oxygen. Most of what you would need to build a space colony. Missing from the moon are organic, carbon-based materials and water, though there may be water trapped near the moon's poles. But what makes all moon materials unique, by comparison with the Earth, is that they are already up there in space. The Earth, 80 times more massive than the moon, 250,000 miles away. Both Earth and moon sit in what are in effect gravity wells in space. The Earth's gravity well is 4,000 miles deep. That's how far you must throw something to get it off the Earth. The moon's gravity well is only 200 miles deep, so throwing things off the lunar surface is very much easier. To do just that, O'Neill came up with the idea of a mass driver, a giant catapult that would accelerate sacks of lunar rocks in buckets. The sacks of rocks would be hurled into space. The buckets would slow and return to be filled again. This is a model lunar mass driver being built at MIT. O'Neill spent a year there working with the designer of the Magna plane and with a group of graduate students who did most of the work. One of these students is Kevin Fine.
It's not very often that a graduate student gets to work in a field in which he can apply basic knowledge. I mean, he can contribute directly to the design. Now, I feel like one of the Wright brothers or something, just beginning to work in a field that has a great future.
To make sure it triggers.
Nova filmed the MIT mass driver on the day of its first test.
5, 4, 3, 2, 1, fire.
This first model is not superconducting, but it still accelerated the vehicle to speeds of 80 to 90 miles per hour over a distance of 6 feet, an acceleration of some 25 G, as compared to a sports car's 1/2 G. A real mass driver throwing rocks into space from the moon would be a mile or two long. But a mass driver throwing mass in one direction would itself be forced, like a recoiling rifle, in the other. So a mass driver, free in space, powered by sunlight falling on solar panels, would be pushed along like a rocket.
It would be possible to take one of these mass drivers and, with a very gentle shove, put it on an orbit to one of the Earth-approaching asteroids. This asteroid might be, 200 meters across, weighing 10 million tons. The mass driver would then rendezvous with the asteroid, glom onto it, and then would gently nudge the asteroid. By Newton's third law, little pellets would come out the back end, and it would go along very gradually for a period of, we'll say, 2 or 3, maybe 4 years, and would arrive in a high orbit around the Earth.
Everybody's ready, Bill? Ready? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire. Just a second, folks. I'm going to calculate the acceleration on that one over here. Can we see that again?
Derail.
Yeah, that's right. 5, 4, 3, 2, 1, 0. Calculated the acceleration. It seems that we still have some problems. We only got 33 Gs on that shot.